chugging right along here. What we're going to do now is see if we can make a go at evaluating the two competing hypotheses that were written out on the previous page with the data that we have collected here. So we will end up using the normal distribution in this calculate step. Much like we did with confidence intervals, there's this condition that we're going to check to make sure that the sampling distribution of the sample proportion is approximately normally distributed if the null hypothesis is true. So remember, the null hypothesis said that the proportion of matches we win is 0.25. So if that is true, then the condition we're going to check is we're going to throw in this p naught value in for p, because we're assuming the null is true, so that gets plopped right in there. And other than that, the condition is the same as it was when we did confidence intervals. So we're checking to see that both of these values are larger than 10, and the condition holds in this particular case. There's also this other independence assumption that we are not quite going to talk about, or that we're not going to talk about quite yet. We're going to jump straight to calculate. And so what we want to do is we want to find the sampling distribution of this sample proportion, but we want to look at that assuming that the null is true again. So again, assuming that the true proportion is 0.25. Under that assumption, our standard error becomes this. So again, since we're still assuming the null hypothesis is true, we plop in p naught for p, because we're making this calculation assuming the null is true, or assuming our true proportion is 0.25, and then we could calculate this value. And so the standard error turns out to be 0.061. So that is, if you recall, that is the standard deviation of the sampling distribution. Getting down into the crux of it then, if our sampling distribution is approximately normal, and if we assume the null is true, the standard deviation of that sampling distribution is 0.061, what we're going to do then is draw out this null distribution. So if we were to repeatedly play 50 matches millions and millions of times, and if the true proportion is 0.25, we're going to draw out what the sampling distribution would look like. So based on the check, the sampling distribution would be approximately normal. If the true proportion is actually 0.25, so again, we're drawing this assuming that the null hypothesis is true, it's going to be centered at 0.25, which is our p naught, and it's going to have a standard deviation of 0.061. So I'm going to use that 68, 95, 99 rule to help me draw my tick marks in approximately, and so that would be 0.311. I'm just going to go 2 tick marks out, and so that would be 0.372. On the other side, 0.189, and that would be 0.128. And so what this is a distribution of the sample proportion if the matches are decided by random chance. So if the matches are decided by random chance, a lot of the times we're going to win about 25% of the time, but even if they're decided by random chance, some of the time we might win 30% of the matches, some of the time we might win, 18 or 19% of the matches. And then it would be really unlikely, like down here, if they were decided by random chance, for us to never win a match and for this to be 0. Or if they were decided by random chance, it'd be really unlikely for us to win, say, 50% of the matches, because that value would be way over here, way in the tail, super, super unlikely. Okay. So where does our sample statistic p hat fall on that distribution? Well, I'm going to flip back and I'm actually going to mark it. So remember, p hat was 0.32. It was the 16 divided by 50. So that is where our observed sample proportion falls. Then, answering this question, how unlikely is it to obtain our value of p hat, which again is 0.32, if the null hypothesis is true? Well, it's kind of in the tail, but it's not like that far off of this distribution, so it's not that unlikely. And we're being somewhat vague here. So how unlikely? Well, not that unlikely because it's not that far into the tail. There's a couple of follow-up questions then. So what if our p hat had been 0.43 instead of what we actually observed? Would that have been an unlikely value? Well, let's look at where 0.43 falls. It's way over here, way in this tail somewhere. So yes, 0.43 would have been very unlikely. If the null is true. And again, what the null hypothesis says is that p is 0.25. So that value of a sample proportion would have been very unlikely. 0.26 is right smack in the center of the distribution. So that would have been not unlikely at all. So it's right in the middle. So 0.26 would not have been an unlikely value at all if the true proportion was 0.25. Okay, so I think I'm going to stop this video there and we'll pick this up in the next video looking at formalizing some of our logic up here.